So earlier I opened up my Advent of Code helper to see if everything still worked. So I set it up and it's still loaded, so that is nice. So I think we'll just start reading the problem set for today. Kind of bummed that it's only 12 challenges this year, but yeah, being as busy as I am myself, I can totally understand that Eric needs some rest and can only do 12. So let's just enjoy what we have. So yeah, let's see. Day 1, secret entrance. The elves have good news and bad news. The good news is that they've discovered project management. This has given them tools they need to prevent their usual Christmas emergency. For example, they now know that the North Pole decorations need to be finished soon so that other critical tasks can start on time. The bad news is that they've realized they have a different emergency. According to their resource planning, none of them have any time left to decorate the North Pole. To save Christmas, the elves need you to finish decorating the North Pole by December 12th. Okay. Collect stars by solving puzzles. 2 puzzles will be made available on each day. At least that's the same as previous years. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. Let's see. You arrive at the secret entrance to the North Pole base, ready to start decorating. Unfortunately, the password seems to have been changed, so you can't get in. A document taped to the wall helpfully explains. Hey Amarte, welcome. Hi Mama Plies. Mama Plies is the account of my wife, but I think the kids are watching right now, so it's always nice to have everybody here. So welcome. Thanks for joining me. It's nice. I hope everything is okay. I had some trouble setting up the stream, so if the audio is off or something else is wrong, please let me know. YouTube is complaining that the bitrate is lower than expected, I think, but I hope everything is fine. It's good to see everybody again. Let's see. The password seems to have been changed, so you can't get in. A document taped to the wall helpfully explains. Due to new security protocols, the password is locked in the safe below. Please see the attached document for the new combination. The safe has a dial with only an arrow on it. Around the dial are the numbers 0 through 99 in order. As you turn the dial, it makes a small click noise as it reaches each number. The attached document, your puzzle input, contains a sequence of rotations, 1 per line, which tells you how to open the safe. A rotation starts with an L or an R, which indicates whether the rotation should be to the left, towards lower numbers, or to the right, towards higher numbers. Then the rotation has a distance value, which indicates how many clicks a dial should be rotated in that direction. So, if the dial were pointing at 11, a rotation of R8 would cause the dial to point at 19. After that, a rotation of L19 would cause it to point at 0. Because the dial is a circle, turning the dial left from 0 1 click makes it point at 99. Similarly, turning the dial right from 99 1 click makes it point at 0. So, if the dial were pointing at 5, a rotation of L10 would cause it to point at 95. After that, a rotation of R5 would cause it to point at 0. The dial starts by pointing at 50. Okay, so that's good to know. Need to put that in later. You could follow the instruction, but your recently required official North Pole Secret Entrance Security Training Seminar, NPSESTS, okay, taught you that the safe is actually a decoy. The actual password is the number of times the dial is left pointing at 0 after any rotation in the sequence. For example, suppose the attached document containing the following rotations. Okay, we have a bunch of rotations there. Following these rotations would cause the dial to move as follows. Okay, so these are some steps here. It points at 0. Because the dial pointed at 0 a total of 3 times during its process, the password in this example is 3. Analyze the rotation in the attached document. What's the actual password to open the door? Okay. Seems simple enough. Since it goes from 0 to 100, starts at 50, and it has wraparound, it seems like you would just do a modulo 100, right? So if you go, if you just do a mod 100, that should give you the answer. But that probably doesn't prepare us very well for the next part. But yeah, let's just do it. As a test, I wrote this to see if it still works, so it will just dump out the whole input. So if I run this, boom, it will just have all the numbers here. So yeah, that's fine. It's fun. There are 3-digit numbers here as well, so that's funny. Marta says, I'm in the remote meeting, so one eye on that and another on your stream. Well, it's nice of you to pop by. Thank you. And good luck with the meeting. I hope I'm not keeping you too much from it. So yeah, we have for part 1, we can put in the test, but I don't. Yeah, well, why not? We can put in the test. Here's the test input, and the expected answer is 3. So I can do this, and then answer P1 is 3. Okay, so now we implement it here. We start at 50, and we do input 2 lines. 2 lines. For each string instruction. Okay. So we have const char rotate left is L, rotate right is R. And basically this maps to what we need to do. So we can do if instruction 0 equals rotate left, or we could do this in a switch actually. Switch. Well, case rotate left. Rotate right, default console.writeLine expected n expected instruction. Actually, we can just dump out the full one. And if this is an empty string, it will actually break. So we can do if string is null or empty. Don't care about white space because that would leave us at least one character that we can target. Continue. Let's also write it out so that we know when we encounter it. So we can just say, okay, input contains empty lines. Okay. So now the actual amount that we need to rotate, we declare a variable. Hey Smap, welcome. It's been a year. How's your year been? Nice to see you. So we do int, it could be uint, but we don't care. We just do an int value, and then we do up and down. Okay, I hope not too down. Anyways, it's nice to have you back and enjoying Advent of Code. How are you feeling about the 12th day instead of 25? I understand, it's such a shame because I really like doing the Advent of Code every year. But we should be happy with what we get, I guess. Let me see, what was I doing? I should actually turn off these things, but value is in.parse, and this would be instruction. That. Like this. So then we do a bit of a shame, but he's been doing it for 10 years now. He's earned the break. Yeah, for sure. Yep. Yeah, we can be very happy with everything that he's created, and for free nonetheless. So I'm really happy with what he has created. It's just sad that it's the end of an era, you know. But it's not that yet. Let's just enjoy these 12 days. But I'm really curious to see how it will ramp up in difficulty. So the easiest way to account for everything would be to mod this actually, because it's a max value of 99, so mod 100 would be the answer. So any value that you process here, you could do mod 100. So if it's like plus 540 or minus 3000 blah blah blah, it doesn't matter, because every 100 it wraps around, so we only need to process the remainder of 100. But then if you have 5 and you want to go under, I actually can just do that, and just if it's below 100 just add it again. So I think that would be the easiest way. So we do p1 plus equals value if p1 lower than 0, p1 plus equals 100. That would be the logic here. Sure, and value is 0. So this would be the basic logic, right? We have all L and R commands. Those can be numbers. We mod them to make sure that we stay in range. And in the end, we can still do if P1 larger than 99, P1 is P1 mod 100, right? So in this case, we don't care about if we go above 100, because everything remains the same in the end. But we do make sure that if we go under, that we just keep it positive. Not sure if we need to do this in the end, actually. But it's fine. Actually, view, let's see, other windows, C# interactive. So if we do min 344 mod 100, what would that give? Minus 44, sure. Yeah. I'm just wondering if we would not care about doing this and we just do it in the end. So what you could do here is not care about any of those. So we could even not care about it here, right? And in the end, we do P1 like this, and then if P1 below 0, P1 plus equals 100. Like this would cover all the bases, I think. So yeah, let's see if the test case works. P1 is 30. No, actually, haha. That's the first mistake already. So we need to have a running, we need to keep track of how many times current value, and we do long p1 0. So here, okay, we need to determine it in the end. And I wonder, like, my thinking is, what would it make sense to do the modulus stuff all the time and keep it in range, or just do like one test each time? But if you do the test, you might as well update it, right? So since we need to check for if we hit 0, we might as well do the modulus thing every time. So what we can do is here, so we could do current value equals plus value modulo this. If current value equals 0, P1 will be incremented. And in this case, we don't even care if we're negative, because it will always round to the 100, even if it goes from negative, so that should be fine. Yeah, I think this should work. I renamed this current value. This needs to be P1, and P1 is 3, so this works. With my renaming, I also renamed it P1. So that is fine. Okay, the test value works, so let's go to run the not so much test. And it says, that's the downside of renaming it, when you expect it to be there. So this will be 1081, and let's see if this is correct. Woohoo! First gold star in the bag. Okay. Nice. It's, thank you, thank you. Let's see, part 2. You're sure that's the right password, but the door won't open. You knock, but nobody answers. You build a snowman while you think. That's a good way to spend some time. As you're rolling the snowballs for your snowman, you find another security document that must have fallen into the snow. Due to newer security protocols, please use password method and then some hex code until further notice. Okay. You remember from the training seminar that method blah means you're actually supposed to count the number of times any click causes the dial to point at 0, regardless of whether it happens during a rotation or at the end of one. Following the same rotation as in the above example, the dial points at 0 a few extra times during its rotation. The dial starts, sure, blah blah blah, okay. In this example, it points at 0 3 times at the end of the rotation, plus 3 more times during the rotation. So in this example, the new password would be 6. Okay. Okay, let me click to respond. And why can't I? That's annoying. I wasn't in mod view. Ban and report, and this would be spam. Next, spam. Sure, confirm, close. So annoying. But yeah, let's see. See if you can remember how to mod. Not sure what you mean by that, but it'll be fine. Okay. I wonder if the method name is like a cheeky version of the answer. But part 2 test would be 6. So for part 2, let's just copy paste this for now, because it's pretty much fine as a starting point. My initial thinking was, okay, I'll take the stuff that I did before, like with the value. You divide it, you floor it to get the number of extra click from the rotation. Let me think. Because you don't actually need to do the full thing. What you actually need to do is to see if the remainder of the, like if you take 150 as an input, that means there's 50 in a change of 50. So you need to make sure that that one crosses the boundary, and then you do like the remainder or the division divided by 100 to see how many extra times it has. So you do p2 plus equals math.floor value divided by 100. You can cast it to int. So these are extra full rotations that you do. Actually, I can use just int truncation, right? I can do 3, 4, 5 divided by 100 would be 3. Yeah. Why am I making this harder? I can just do value divided by 100. But I need to make sure that I have the positive or negative value. Because minus 3 like this divided by 100 would be minus 3, right? So we don't want to do that. So we need the math.apps this. So that would work. So these are the extra full rotations that you get besides the actual part there. So I can do this actually in a different way. So I can do it like this. Value is this. So we do extra rotations, do p2 plus equals value divided by 100. Int remain is value mod 100. We should probably do a nice const like dial size equals 100. Right. Something like that. So we do dial size like this. Something like that. Boom, 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 boom. So we do it like this. So this take off the extra full rotations, remain process. So in this case, we can do current value minus equals remain. And then we can do if current value below 0, actually below or equals to 0. This. Actually, they say in addition to, right? So during or at the end of one. Yes. So that counts. And then we need to do, come on. If current value smaller than 0, current value plus equals file size. Just do it like that. Yes. So now we don't have to do this part. Same thing here as well. We do current value plus equals remain. If current value is larger or equal to file size, boom. If it's larger than current value minus equals file size, like this. Because we only process a remainder, we can never be more than dial size off. So now we always keep it in range, I think. Hey, the Ryushinaka. I'm so bad at names. I'm sorry for butchering that. Said, hello Nick, I was wondering if you would if I would see you stream AOC this year. Yes. I know it's weird to see me just pop up and stream only in December. Every year I make plans to stream more because I really love doing this, and I wish I would find a way to fit it into my schedule and everything, but it hasn't happened yet, and I don't think this year will be any different, but at least I enjoy AOC a lot. I enjoy streaming it, sharing it with a few people that also enjoy AOC. So yeah, I've tried to do it every year for as long as they will do it and I can do it. So, and it gets more difficult every year because schedules are busy and customers need to have stuff done, but yeah, I'm happy to still be able to find time, make time wherever. So yeah, thanks for joining and keeping me company in this December yet again. Where was I? I was thinking about this. Let's see if this test case works first, because I did some math there to see if my idea is correct. P1 is 8. Okay. So no, my code isn't correct. So let's see what the issue is there. So let's just step through it to see what it does, because actually whenever I do this, when I run into something like this, what I find that helps is just make an output that looks like the output that AOC gives you. Okay. So that it becomes really easy to compare and debug. So I can say console.writeline. So I could say if it's left. Basically, if I do this, it should at least point out the steps, and I assume that is still correct, but let's just verify. So rotate it L to 82, 52, 0, 95, 55, 0, 99, 0, 40, 32. Okay, so at least that part is still correct. So now we need to figure out where the 2 extra rotations come from. So let's see. Oh, wait, I do something wrong here. In the I didn't update the rotate right probably. Let's see. No, okay, that's not it. Let's see. Current score 2. Let me just remove this because this is no longer needed. Boom. Let's run it again. Noina says, hello again. Cool to see you streaming AOC again this year. Yeah, thank you. Thank you for keeping me company and joining me as well this year. Happy to be back. So let's see. Our code. Boom, 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 boom. It started at score 1 here already. That's weird because it should start at 0. That is good. I wonder why it started at 1 instead of 0 here. Oh well, that's actually correct because it flipped over once. Yeah, so this is correct here. And then it doesn't, that's also correct. Then it goes there. So yeah, it is 1, 2, 3, 4, 5, 6. So they count 6 times there. Okay, so why am I increasing it here? Okay, it goes up here to point at left 5 to point at, so this one is incorrect. What's happening there? Maybe just step through it just to be sure. So this is the left 86, so this is correct. Yeah, because this one is not larger than that value. Current value is that. Sure. That's also still correct. 48. Wait. Yeah, so that one is 100. So that one increases this to 2. That's fine. And that, wait, that points it to 0. Would that add another? No, that doesn't. Let's see. Because what is the instruction here? It's left 5, so it wouldn't. It starts at it starts at 0, so it doesn't overflow. It shouldn't count. Like this one shouldn't trigger if current value started at 0. Sure. Boom, 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 boom. So it would be something like this, but I'm not sure if this is the most logic way to do this. Because I believe if I run this now, it will give the right answer. No. Let me see. It's great that I'm already debugging on day 1. Let's see, debug. Here, this is the case that I meant. It's a current value. In this case, it's plus. Okay. Sure, okay. So that was my issue there. I did it the other way around. I didn't fill in this one. So the actual P1 is this. So I always forget to put in the real answers. Let's see if this is correct now. Woohoo! Second star done. It was a tricky one, the one where you start at the where you start at 0, and I counted that one double. So it's nice of them to have the good test cases in there that you catch not so bright bugs like that. So yeah, I really like that they managed to at least put something in there that trips people like me up, so that there's still a challenge on an easy day. That's just probably because I wasn't thinking properly. I just don't know if I like this, because it's probably I could do like bool from 0 is false, and then you could do like from 0 is current with 0 like this. Then you can do if not from 0. That's probably a lot lighter than the other one. Something like this. So a small tracking variable with just a simple equality statement is leaner than doing math, but let's see if it still works. That also works. I probably also don't need this debug line here. I can just remove it. Okay. So I'm just looking at the code to see if there's anything else that I would want to do. Black Eye says some people were uploading some test cases with R50 and similar. Congrats for the 2 stars. Yeah, thank you. Thank you. It's I don't remember the last time that I had to actually debug and think harder about what I was doing wrong on the day 1. So, but that's probably just on me. I also started to introduce variables late, like the dial size, but that was just because I didn't really know yet where it was going. Kind of curious to see what everybody else did. So let me check the Discord. Boom, 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 boom. Yeah, for those that want to join and share their code, let's see. Sure, let me drop it in chat. Boom, 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 boom. There. That's the Discord if you want to join. Let's see. Somebody already shared it. They already shared it earlier today, so let's see what you did. Now I'm starting to heat it, I think. My bad. Let's see. Step and direction. Public and distance. Step solution. I always forget to use like the spread, the ranges. I like this notation better than the substring, but I'm just so used to, like, for decades and decades of writing substring, it becomes second nature. Let's see, so distance, direction. Yeah, the same, like int trunk division for the full rotations. What does this do? Steps minus equals 100 times steps. Turned out parsing everything in one go and storing in the list is way faster than parsing in a for each loop. For maybe because of the memory stuff. I don't know. I have like my helpers to just dump it into lines. This just does a split. But like going through, yeah, I can see it being faster just going through that memory once in sequence. Maybe they can even like do some compiler magic to pull some things together and make it even more efficient. They've been doing a lot of work on .NET to keep adding performance steps. The direction help steps. I don't know, but what does this do? Steps minus equals 100 times steps divided by 100. So this... I can see this part where you just you shift it over, and if you hit the spot, you increment the count, and if you underflow, then you increment it, and but what does this do? Let's see, steps times distance, maybe steps plus then step by okay. Okay. Smap says, I have a new 4K monitor this week from sales, so I can now read the tinier code. Nice. I can also just do this. Sorry, like I said, it's been a year since I streamed, so forgive me for any... feel free to remind me of things like this, to blow it up so you can read it. Okay. So yeah, sure. Let's look at Smap's code. Numbers on dial, yeah. Start position, visualize, okay. Let's see what that does. Instruction, visualize, yeah, just a boot, yeah, instructions, input as instruction. You have a type conversion here, I think, probably. Let's see, where is instruction? Yeah, it's basically the same. So why do you cast this, the character to a string as enum rotation direction? It's creating a tuple. Sure. Because I don't have a helper for child. Ah, okay. Okay. Makes sense. Might be time to add it because usually they have like single char mappings for those things. Let's see. Rotate instruction, current position. Like that. Sure. Yeah, the same logic here. Basically, it would also work, right, if you would now write it as left 5, so you could fully write it out. Okay, and then we had another submission here. F sharp. Nice. Not used to reading F sharp, but I think I should be able to make out this left of int. Okay, so this one can be left or right, but it is to be an int value. Okay, parse lines, you map function, it takes this first character and then you map it like this. Sure. So this creates like, does this do the same like as in C sharp, where you can have a type that can be basically two things? Just in this case, it's just, so left is of type movement, the right is of type movement, but the underlying type is an int. It's one of the things that I really liked about C sharp, like C++, where you can have like either something that can be like a number or a full struct of something. More flexible. Black Guy says, yes, C sharp took it from F sharp actually. Discriminated unions, okay. You have a nice fail condition. Floor diff, sure. Do you need to declare this actually? Wouldn't it just already, you have it as floats? Okay. Why did you make it floats? Because like if you do the integer division, you would already truncate it, right? Where do you get floats from? It starts on the end and on zero crossings. Okay. Yeah, this is a notation that I don't quite get, I'm afraid. I will skip over it for now, maybe revisit it in a bit. Get past rotation is movement, match rotation with, right? So, yeah. See, like stuff like this is what I really like. It reads so nicely, right? New sum is sum plus movement, crossing is zero crossings, new sum. Okay. Zero crossing start end. If start is larger or equal than end, so it's a value going up. Okay. I don't quite get what's happening there. The trick is zero crossings recursive. Ah, okay. I'm swapping values to handle negatives easy. Okay. So this, okay. So this will batch in sections of 100 until it crosses. Okay. Yeah, this does not compute in my brain yet. I'm not used to functional programming, but I really like how a lot of this looks. Still having to wrap my head around this, but I really like how the rest looks. The recursion might be a bit inefficient when you reach like if they do big numbers. Like there's a Dutch technology forum called tweakers.net, and they have like a forum called Gathering of Tweakers, and on there is usually somebody that, hey, Noah Bali, hi, welcome on the YouTube chat. Sorry, I have a multi-streaming going on between YouTube and Twitch. So hi on YouTube, welcome. So yeah, what they usually do is they have a much harder version of the challenge. So there will be like 40-digit numbers going left and right, and just have to account for it that way. So even if you have like a hard challenge of Advent code, they usually find a way to even break that and push your solutions to the limit. So that's always a nice way to push yourself. Guy says, yes, recursion here is overkill. Just found out there's an easier way with Euclidean division. Yeah. Well, it's been nice. It's like I really wasn't thinking about Advent of Code too much because I've been so swamped with stuff that I had to do. So usually, like in the run up to Advent of Code, I always start to like, oh, let's look at previous years, maybe do some of the old challenges that I haven't done yet. But now this time, December 1st rolled around, and I hadn't even thought about AOC much yet. So yeah, it's nice. Just for completion, let me just for people that have no clue what Advent of Code is, I'll just drop it in the chats. I assume everybody knows it by now, but Advent of Code is a yearly challenge with all sorts of nice programming puzzles that you complete. And you can participate, and you can see lots of people streaming it on YouTube and Twitch, and yeah, it's just a lot of fun to do. So I think for now I will stop the stream here and welcome you all back again tomorrow. I think I still have all the old streams on my YouTube channel. That's nick.yt. I have a like nice short link, so if you want to watch some of the old code and see me struggle there, the playlists are here for you to watch if you want. So yeah, that's it. It's been fun streaming again. I hope you enjoyed it as well, and yeah, hopefully see you all tomorrow. Bye bye.